Good afternoon, everybody, and welcome back to this RIA event. My name is Frank McGovern. I work with the Environmental Protection Agency as their Chief Climate Scientist. I also have a number of roles with European and UN bodies in climate research and climate policy, including working with the IPCC and UNFCCC. I have the honour of chairing the panel on energy efficiency and buildings. But firstly, I wish to congratulate the RIA and the organisers of this excellent event, which is really timely. This morning, we have heard a lot about the big picture issues, but this panel is really where it gets personal for us. The buildings in which we live and work are really important to what we are and how we live our lives. However, we face major challenges in decarbonising our buildings, but also in ensuring that we do so in a resilient manner. We heard a lot about the Texas incidents, the recent Texas incidents, and the nightmare that they went through. We need to avoid that as part of our planning for the future. So this afternoon, I have the pleasure of introducing first Dr. Lisa Ryan, who is a lecturer in energy economics in the UCD School of Economics and energy economics research. Her research is in clean energy technology, energy markets, and climate change economics. She's a board member of the Sustainable Energy Authority of Ireland. She was a senior energy economist in the Energy Efficiency Unit of the IEA, and she previously worked in policy analysis, including with the German automobile industry. I've known Lisa for many years, and I'm delighted to hear from her now. Lisa, please.
Hello, everybody, and thank you very much, Frank, for that nice introduction. I'm delighted to be here. I really enjoyed the sessions this morning, and they've really set the scene well for, I think, for us for this afternoon. I'm particularly happy to be part of this session. I have wide-ranging interests as an economist in energy and clean energy and climate change, but buildings and energy efficiency in particular is a topic that's very close to my heart. So probably as an economist, that's why I was asked to speak on the economics of climate change in buildings. So this is going to be the focus of my presentation to you today. I just have a few short points. I'm really going to set the scene for the rest of the session. And we have some great speakers coming up who will give more detailed presentations perhaps than my own, which will be quite broad ranging in terms of, how do buildings fit in the Irish CO2 emissions challenge and ambition? And what are the policies that what are the high level policies in this area? Try not to overlap too much with this morning. And then, as an economist, we look at this through a certain lens, and it's really through the lens of market failures. Why aren't we doing more in the session? And then I'll just finish with some policy options. So this is the graph that I think you probably have seen this morning in terms of our emissions. And it's just to remind us again, I'm not sure how many of you were already with us this morning, to show us that, these blue bars are the total effort sharing decision emissions coming from Ireland. And the red line is our targets. The official 2020 numbers aren't in yet, but, given what we had in 2019, I think we can safely say we are off target. We do have, I know that, this morning, Brian Carroll and the Minister gave quite a lot of detail on the overall policy strategy, the Climate Action Plan from 2019, and now we are developing a 2021 Climate Action Plan. But we also have, for the first time, I suppose, properly a bill in place in 2020, where we have set out a national climate objective, where we are going to have a climate neutral economy by the year 2050. And this is really stepping up in terms of our ambition. It should be reminded, though, that we have not met our 2020 targets. So this is not trying to be, I suppose, difficult, but the point is it's going to be more difficult to reach 2030 and 2050 targets, given that we are off track already in 2020 and 21. But there are a few things that are in the Climate Action Bill. Firstly, we're stepping up in terms of our emissions reduction per year, which was already set out in the programme for government, that we're going to reduce by 7% per year. We're going to some details like the 5-year carbon budgets, that I think these elements in terms of institutionally will be very useful. We're going to have an annual climate action plan. We're going to have a stronger climate Change Advisory Council. We have had a very good Climate Change Advisory Council, but they have been limited in their powers to some extent. And the Oireachtas Committee will also have stronger powers as far as I understand it. So there are some elements being put in place, and these institutional arrangements are very important. But this is slightly off topic. Let's come back to buildings. And our residential CO2 emissions. I'm leaning quite heavily on SEAI data here. They have a report from 2018, residential emissions in Ireland. And so the latest data in that report is 2015. But I think, you know, the main points haven't changed. And that is really that if you look at this graph, Ireland is the green at the top, this green line, unfortunately, not this bottom green line. This bottom green line is the EU 28 minimum. This is the average, and this blue is the EU 28 maximum. And going to 2014, 2015, Ireland was at the maximum or even above the maximum in the EU in terms of CO2 emissions, specifically coming from the residential sector. And this is partly because we have the highest energy consumption per dwelling in the EU. And this is mainly because we have larger dwellings. Well, it's not just because we have larger dwellings. We have quite a different building stock compared to the rest of Europe. Only 7% of our dwellings are apartments, which is by far the lowest in Europe. I mean, the second lowest is the UK. Well, actually, they're not in the EU anymore. But regardless, it is 15%. So they have even double what we have. So you can see that our dwellings, we have larger dwellings, and the average square meter per dwelling is larger. And it means that the energy consumption per dwelling is, you know, in 2015, it was 58% above the European average, which is really a lot. And not only do we have higher energy consumption, we also have higher carbon intensity. So this is really one bad news story after another. And it's to do with the fuel that we use in our building stock. Sorry, first of all, I wanted to show you the energy-related CO2 emissions by sector. And here this shows that the residential sector is a significant amount. And if you look at just the part of our effort-sharing decision, in other words, the emissions that are counted for our CO2 target in Europe, it's 28%. Of those emissions are from the residential sector. And this is really because if you compare the fuel mix in the building stock in Ireland compared with other countries, green at the top on these bar charts, green is oil. And you can see that the amount of oil in the Irish building stock is much higher than these other countries that are compared with. This is also from an SEI report. And we do have some gas, but we do have very carbon intensive fuels in our fuel mix. So this is why energy efficiency particularly is extremely important. If we have such a high share of CO2 emissions coming from the energy that is used in the building stock, we need to reduce the energy. So we have two options. We can switch the energy source, or we can use less of it. And the overall strategy in the climate action plan that we have for I suppose not just for the residential sector, but overall, has been that we should reduce energy demand, in other words, improve energy efficiency, and then electrify heat and transport, and then decarbonize electricity. So we can see that firstly, the idea is, you know, if we reduce the demand in the sectors that are producing the most emissions, so it's heat, transport, agriculture, of course. Agriculture is not something that is the focus of this session. Neither is transport, but heat really is. So we can reduce the energy, first of all, used there, and then electrify. In other words, take that oil and the solid fuels and gas out of the building stock by electrifying it. But this, of course, presumes that we will also decarbonize our electricity sector. And the session on heat and electricity, the planning session, Mark Foley, my colleague Damien Flynn, they outlined very clearly the technical challenges associated with decarbonizing electricity, in other words, switching to renewable electricity. And Ireland is really a world leader in terms of how we are approaching those technical challenges. And some of those are very specific to the isolated system that we have in Ireland. So I suppose this is just a broad picture overall: reduce our demand through energy efficiency, electrify heat and transport, and then decarbonize electricity. And that will eventually get us to very low emissions. And of course, deal with agriculture, but luckily that is not the topic I have to deal with here today. And the reason that we're focusing on energy efficiency, this is the MAC curve that was used in the Climate Action Plan 2019, which I won't go into much detail. Some of you are very familiar with these, others this will be like double Dutch. But it shows basically all the different technical measures that we might use to reduce our non-ETS emissions. And everything that is this side of the red dotted line are the abatement technologies that we need to put in place. And they start from the cheapest. In other words, if they're down here negatives, that's the marginal abatement cost curve, costs of per unit emissions. They are negative. As you move across this graph from left to right, you see they become more expensive until they are rising above it. But everything there needs to be addressed, and they're stacked in order of cost. And some of those, you can see that a lot of these actually are to do with decarbonising the electricity system, but some of them are in the residential sector and buildings in general. So switching from oil boilers to heat, it's practically cost neutral. And you have to consider each time we're looking at the costs here that the costs are the upfront cost offset against the benefits that you receive from energy saving in the future. And then we also have identified retrofitting gas boilers and introducing CO2-free heatings. So there has been quite a bit of analysis, and there are other analysis, but this one sets it out, I think, in a very comprehensive manner, how the different technologies compare with each other. The Climate Action Plan has already been talked about. I just wanted to emphasize again that when we're talking about buildings, the 500,000 existing homes need to be upgraded to B2. And this was just in our 2030 action plan that we have to date. And this involves 600,000 heat pumps. So the next session is going to deal with behavior. We've also done a lot of work on this. It's really about trying to address how do we get people to change their heating, change their use, change their technologies. And we have done some analysis looking at the performance of energy buildings in the market. And this is taking all the building energy rating certificates that are reported in the SEI database. There's about 950,000 here, and plotting them all. And we've looked at rental properties and non-rental properties. And you can see that the vast majority of properties are here in the middle. They're between C and D. So to get to a B2 property, we really have an awful lot of properties to move. And what's also interesting is to see the difference between rental and non-rental properties in terms of their energy performance. And we do find when we do statistical analysis or econometric analysis of this, that the rental properties are slightly poor performing, not as bad as we had expected, but they are worse performing than non-rental properties. So targeted policies are needed in the rental sectors. Why is more not done? We know that a lot of the energy efficiency measures and policies, they should be cost neutral, or they even bring positives, that there's a positive, the benefits outweigh the costs. But I'm not going to go into this now, but it's just to show you that when you're looking at this from an academic's perspective, we consider that there are many market failures here. In other words, the market won't be able to do it on its own. There are non-market failures that are also barriers, but the market failures in particular, like externalities, investment inefficiencies, these are things that really need to be addressed with policy. What we have looked at as well is that the market is working a little bit. And since the rollout of BER certificates and the requirement for them to be on all rental properties, now it's not perfect enforcement, I would say, not if you look on DAFT, not every property has one, but you can see that this just estimates the rental premium. We have data from the Residential Tenancy Board. The rental premium associated with a property, here it's A3, for example, compared with D. So D1 is our reference. And you'll see that properties in that are A-rated do have a higher rent than the lower rated properties, which is already very good news, because it means that landlords will get a return on their investment if they do invest in energy efficiency. And we see that there's a difference, last thing, we see that there's a difference between in cities and outside cities. In cities where markets are tighter, landlords will get a better premium on their properties, on efficient properties. So there are some policy options. I'm just going to finish up with these last few thoughts. The market failures that we see, in particular in the rental sector, are a landlord-tenant problem, and there are specific policies that are being put in place, particularly around the labelling of energy performance of properties. But we do need much better enforcement in the rental property market. Asymmetric information, this is also being addressed with labelling. Sorry, I should have said in the landlord-tenant problem, there are some split incentive problems here that probably will require some regulation as well as labelling. Externalities we are dealing with in terms of carbon taxes and energy prices. And what will be important in the context of decarbonising the electricity sector is making sure that we have time of use pricing, so that people are not using their electricity at the times when we don't want them to be using so. Access to finance is very important in the energy efficiency sector because banks often do not understand exactly how to deal with very technical retrofits. And so you do need to have low interest loans coming from credit lines, maybe from government, grants associated to defray upfront costs, and a range of other measures. And then finally, behavioural measures, which I think will be more addressed in the next in session, but one-stop shops that help consumers on their path so that they can go to one place and find out what measures they can do, who will be the local person that will do it for them, and how they can get finance for it are very important. And this is something that's being rolled out in Ireland now. But a mix of all of these policies. I'm not going to lie and say that one of these policies is going to solve the problem, but to get to 500,000 B2 homes, we will need everything and, supercharged policies. So finally, I'm just going to finish up saying that, just to recap, the takeaway messages are that we really do need energy efficiency. Although you might have thought from the last sector, we're going to decarbonize electricity and that will do the trick. We still do need a lot of energy efficiency improvements to reduce wastage, to ensure that we aren't, wasting resources. And efficient markets, you would think, should drive this. But there are market failures that will mean that we do need to have policy. The scale of ambition is so large that we do need technology and behavioural change with strong policy measures to implement them. And I always like to say that we definitely need to have more policy modelling to understand what is working, so both ex ante and ex post, to ensure that we have evidence-based policies put in place. And that is my short contribution today. Thank you very much.
Great. Thank you very much, Lisa. And I think the message about helping people make sense of the solutions is really a good one there, along with all of the other fine material that you presented. What I would like to say to people is, please use the question and answer section for putting in your questions. I see there are a few questions in already, but just use that section rather than the chat area. And Lisa will come back to questions at the end. And right now I will move over to our next presenter, and that's Professor Brian Norton. Brian is an internationally renowned academic and author. He is head of the International Energy Research Centre in Tyndall's National Institute in UCC. Previously, he was president of Dublin Institute of Technology and principal of the city campus of TU Dublin. He's a qualified physicist from University of Nottingham and gained doctorates in engineering from Cranfield and the University of Nottingham. He's a fellow of the Energy Institute, Engineers Ireland, and the UK Higher Education Academy, and an honorary fellow of the Chartered Institute of Building Services Engineers. And that is only a small number of his awards and recognitions. But Brian, I hope you're ready to start to talk to us about, I suppose, some of the solutions that Lisa has pointed to in presenting decarbonisation of buildings. I'll hand over. Brian, are you with us?
I'm off mute and I am going to share screen. Can you see the screen?
Yeah, we hope to see it.
Is it there now?
Soon. Yes, great.
Brilliant, brilliant. Yeah, go to full screen. Apologies there, got a little connection problem.
Okay, Brian, please.
Okay, good afternoon, and thank you very much for the introduction. What I'm going to talk about is work that's come out of European Academy's Science Advisory Committee steering group on decarbonisation of building, which advises the Commission. So it's very much on a European perspective. Talking about some of the principles, and Lisa has already outlined these in considerable detail. Essentially, what to decarbonise buildings is reducing the energy demand from buildings over time and increasing the supply of electricity and indeed heat to those buildings that come from renewable energy sources. And over time, the little coloured graph on the right there shows the decline in the requirements for energy use in buildings from various European jurisdictions. The key thing is displacing gas, oil, solid fuels with renewable electricity and renewable heat. In new buildings, a new building in itself can be near zero energy. And if it's got solar water heating, photovoltaic panels, and other local electricity generation, for example, and indeed heat generation, can share that energy with other buildings and end up with a set of net zero energy buildings, a net zero energy apartment block. And there are many, many routes, technical routes to doing this. Some of the illustrations, some of the buildings here show different approaches to that, either with large amounts of south-facing windows or buildings with very few windows, very tight form, and the ability to move heat and indeed electricity from parts of the building that can collect that to parts of the building that need to receive it. The other key part of this is that in the building being able to produce energy and producing net zero buildings and net zero energy communities, the building occupant moves from being a consumer of energy to being a producer of energy, a so-called prosumer, and that again changes the nature of the market. So in new build, there are lots of technical options that are well developed. Unfortunately, new houses are a minority. Now that might change. There are imperatives to build a lot of new houses, but nevertheless, new houses are a minority. And if you look at the energy ratings, the red here, the share of dwellings with labels greater than D across Europe, will show that these are a large number of buildings are old. In the little thermograph at the bottom, you see one building that is refurbished in a line of buildings, and the challenge is actually how to improve the energy efficiency of the existing stock rather than just focus perhaps on new buildings. That is a challenge. Here's an example of a renovation. This one's actually in Estonia. On the left, the building before, on the right, the building after. But it indicates some of the things that are done. There's improvement of the insulation standard of the building. There's improvement of the air tightness, replacement of the glazing. And in this example, there is the balconies have become livable area, what's called a volumetric addition. In other words, a benefit to the occupants. These are social housing units. The benefit of the occupants is in the refurbishment, they've got additional space. And also there's a general improvement of the space, a general improvement of the air handling, etc. So it's very straightforward. But a lot of the things come is that if you think about the energy labeling, for example, of a washing machine, its sole function is to wash clothes. The energy labeling of a building is not quite the same, because the function of a building are to supply a whole range of comfort and amenity to occupants. And those things are what the energy is needed to do, rather than be an energy efficient system in itself. And the root of those are some of the challenges. The first one is actually energy rating itself. The actual energy consumption of buildings, an example here, for example, of buildings that use gas for heating, the theoretical and the actual are not the same as the energy rating. And there are a number of reasons for that. Energy rating is against a standard set of reference conditions, and a particular building at a particular time will not be in those reference conditions. The occupancy will be different, the climate will be different, etc. But also when ratings themselves actually happen, they do use a particular procedure, and that procedure will have default values for doing the ratings that will default the building to its time of construction. So someone who's doing the rating will use a particular default value in the software. That will inevitably mean that buildings are rated to be worse than they actually are, because buildings are often being improved surreptitiously over the years by their occupants in a variety of small ways. That means their performance is better than their time of construction. There's also the fact that buildings are occupied in ways that are not always energy efficient in themselves, and Lisa's already discussed the issues of the size of buildings. So energy rating is not a measure of the energy performance of buildings. It's a guide, but it's not a measure. And you can see my sort of dotted line in between two blue kind of limits around that. So there's a problem with ratings itself. The other issue is, and this was touched on in Donna's contribution on district heating earlier on, is that one needs to avoid peaks in electricity production. There's a lot of stranded assets in producing electricity just for one coldest day in winter. And so in designing a system at the demand side, one needs to be aware of the need to avoid those peaks and provide appropriate storage in the system, which could be local to the building, storage of heat, storage of electricity, and also movement of heat between buildings through district heating schemes, and movement of electricity between buildings, which might be, as the prosumer, but that also might be through in the future through electric vehicles that might be charged in one location and actually provide energy storage to the building when they return to it at the end of the day. Um, I have a little graph there on the capacity of heat pumps in the depths of winter. There's also important things that capacity on heat pumps is correctly sized. Otherwise, although you might have heat pumps replacing electricity and having good coefficients of performance, the sheer number of them will actually mean that the winter peak is still the same. So there are macro issues that need to be looked at in terms of buildings as well. There are also some very particular issues to do with buildings themselves. I'll pick on two. There are many others. Indoor air quality. One of the issues with improving efficiency of building is they become airtight, and that in itself is not healthy for the whole range of reasons that are given on the diagram on the left. And these have been brought to the fore very much in the pandemic, where the ability to change the air change rate to flush out viruses from building has become more apparent to many people. Key things here are to have mechanical ventilation heat recovery, designs of buildings that can do that successfully, or some preheating of the ventilation air. But it is a very key limiting factor in successful design of buildings and needs to take account of occupancy and ideal cultural practices around cooking and such like. Another one, and perhaps less considered, is actually daylight. Daylight in buildings is important from a point of view of biorhythms and what's called circadian health. It's important from the point of view of the proper eye development in children. And it also displaces electric light use. And there's a whole range of potential benefits. And one tendency in buildings is to reduce the glazed area and then have a very high electric light use. Interestingly, one thinks of lighting energy use as being very small, and it is relatively, but of course, as other parts of the building become more efficient, it becomes a greater part of the energy use. And although energy lighting in itself is more efficient, if you go back to the past, there might have been one incandescent lamp in the middle of the room. That'll have been replaced with efficient LED lightings, but possibly replaced by 10 of them recessed in the ceiling. So although they might be 10 times more efficient than an incandescent light bulb, there are 10 of them. So actual lighting energy use has not gone down. And that's kind of one of the examples of rebound effects that happen in buildings. Another one being, for example, that if you have an energy efficient building, occupants will legitimately take higher comfort temperatures of the building, and so you won't realize necessarily the energy savings that one would envisage. So it's important to bring the human factors into how buildings are actually considered. The final one is a slightly different one, and that is that we tend to focus on the operational energy use in buildings, the buildings that how it actually uses energy time. But there is embodied energy, there's embodied CO2 emission in the materials that make up a building. And this is particularly important when looking at renovation, because it's possible, if you use the wrong materials, that there's obviously an increase in the CO2 emissions associated with the renovation process itself. And that can increase the short-term CO2 emissions of the building at the very time when we actually want to reduce them to meet the targets that have been ably described by the earlier speakers. The key thing actually, and there's a pyramid of different materials there illustrated on the left, is to use less carbon intensive materials, more wood, more organic materials, and less materials generally. And wherever possible, if using steel or stone or whatever, is to use that from recycled sources that are fairly local, because the transport energy use otherwise would come in. So important to consider not just the operational energy use, but what are called the life cycle emissions, include the emissions from the embodied energy in the building. And some of this has been touched on far more ably by Lisa, but there are very key issues on approaching the financing of the energy renovation of building. And the key thing that is the elephant in the room is fuel poverty. And for many, many groups, the opportunity to do renovation is not affordable. They're also tenanted in situations where the landlord may not actually provide it. And there are actual policy incentives around given price signals, which can actually lock those in fuel poverty into that situation with no financial means of getting out of themselves. So the approaches to financing energy renovation that are fair and equitable are a major challenge. There's a lot of work both in Europe and certainly in Ireland on mechanisms that can work, but it is important that addressing those who are least able to afford it needs to be the major part of that challenge. So, to conclude, a very broad calculation. This is showing the EU's current planned renovation wave. The units on the top left-hand side are in millions of tonne of carbon equivalent, and showing that the EU renovation wave, all other things being equal in a very broad sense, should be able to achieve by about 2043 the reduction to that would enable a 2 degrees Celsius temperature rise. Business as usual, not doing the EU's renovation wave, would not do that. But interestingly enough, it would not achieve the current renovation wave, current renovation plans. The 500,000 in Ireland renovated buildings being part of that will not actually achieve a 1.5 Celsius temperature rise. So it is important that even the present plans are looked at as not so much a stretched objective, but the minimum that needs to be achieved. Now, there are a lot of caveats around this number. I don't have time to go into them today. There are a lot of caveats around this, but the plans are by no means radical in terms of what needs to be achieved. There are many other aspects of this which I don't have time to, I just want to show this just to deal with some of the other issues there, which are to do with training and particular aspects of how buildings are actually operated and monitored and ignored. But there are many other aspects I'm dealing with today. There are also many players within this. If you looked at it from perhaps a technical viewpoint, it's architecture, it's related to the climate, it relates to planning regulations, and as Lisa described, a lot of economic factors. There are also multiple stakeholders, but those stakeholders' interests do not converge. And those who are in the social, the environmental, and the economic have very particular interests. I think the key challenge is, although there are multiple benefits that accrue, it's how, and I've used the World Health Organization's Venn diagram there for their Healthy Cities Initiative, how you bring those different stakeholders to bear in a coherent approach to energy buildings. I'll conclude there. Thank you very much indeed.
Thank you very much, Brian. And that was really a fascinating run through an awful lot of interesting insights. And I suppose what came out for me was the various human dimensions that you mentioned, and also the multidimensional life cycle analysis of our buildings and what that entails and the complexity of it all. But as I say, we'll be coming to questions and answers later on, and do put your questions in to the questions area, the Q&A area, rather than the chat area, so that we can see them. I'd like to now introduce our final speaker for this panel, and that's Dr. Matt Kennedy. Matt holds a PhD in engineering from Trinity College Dublin and master's degrees from NUI Galway and UCD. He's Associate Director for Europ's Ireland's Carbon and Climate Change team, where he leads on carbon and climate change services and sustainable development within infrastructures, buildings and cities. He has significant experience in management and delivery of complex multidisciplinary projects and has worked on the UN technology needs assessment and energy market transformation and various other international projects across Africa, Asia and the Middle East. Previously, he was head of strategy and business with the International Energy Research Centre of the Tyndall Institute in UCC, and he obviously worked with the EU in its work under the UNFCCC, the UN Framework Convention on Climate Change, on technologies. He's a member of the Irish Academy of Climate and Environmental Sciences, and today he's going to talk to us, I think, about that other dimension to our buildings, their resilience, and their resilience for the future, for now and for the future. So Matt, if you're ready, please provide us with your presentation. Thank you.
Yes, thank you, Frank. I hope you can hear me okay.
Yes.
So it's my pleasure to speak this afternoon, and many thanks to the Royal Irish Academy for the invitation. It's great to get the opportunity to talk about resilience, because it's often used when problems happen. So you could hear the term resilience last week in terms of the resilience of the grid, or you could in terms of the power outage in Texas. Around COVID, you could hear it in terms of resilience of supply chains. When Galway or Cork flood, it's often around the resilience of the response and the resilience of those buildings. And really what I'm going to do is to talk about it in terms of a response, but also preparation and the role that it would play, especially around climate. So if I can just go to manage these slides a bit to see the next slide. Okay, so the focus of the few minutes on resilience is about identifying why we should be considering it. And in many ways, it picks up on what Peter Thorne mentioned around adaptation, the idea that we're going to recognize that we live in a changing world that is a changing climate. And in terms of the resilience and the adaptation towards the changing climate, we need to define what it means, but what grounded in what we mean, like what is resilience, resilience of what, to what, for whom, and making the shift to resilience. And I'll ground it within the built environment. So I'm using just an intro here from the Rockefeller to talk about resilience in terms of the capacity of both individuals and communities, but also institutions and businesses. And they coined the term of survival, adaptation, and thriving. So ultimately, it leads to individuals or organizations thriving. And what I find really interesting for this, with this definition, is the term stress and shock. So it's in many ways a response to that, or preparation for future stress and shocks that they may experience. The types of resilience then, so we can see there are three types. I'll focus a little on the transformative one in terms of the built environment, but in many ways, from a structural perspective, it's built into a system to ensure that there is a safe failure. So when things fail, that they can do it safely. The integrative version really is that the system may join together with other systems. So we talk about these integrated systems, but so those systems become stronger and then they're able to respond to the change. But the transformative one is the one that's interesting. So how systems, sorry, we've moved on a bit, how systems adapt to the shock, to stress, and how that can result in more positive change in terms of design, change in terms of planning, change in terms of the way organizations respond. So that's in many ways the transformative focus that I want to touch on. It's the resilience of what? And I know this session is really around the built environment, but building resilience of that environment means, you know, increasing the scale and what areas we're really talking about in terms of scale. The physical assets, we know them in terms of our buildings. We know them in terms of the portfolio and how those buildings interact together. And they could be houses, they could be community buildings, they could be buildings such as school buildings. But the infrastructure then in terms of the networks, and this infrastructure in the ecosystem spans across buildings within urban and rural settings. So you can see really in terms of the resilience of this infrastructure in terms of transportation systems, which I'll talk about a little later, but in the grid and the rolling blackout that happened last week. So whether it's gray or blue or whether it's green infrastructure, this is what we're focusing on. The organization, the supply chain around COVID was a good example of how you would need to build resilience in terms of supply to organizations and to individuals, and understanding how those organizations rely on the built environment, such as an example, airport authorities or transportation operators. And then finally, the places, which are the cities, the districts, the communities. So grounding resilience in terms of threats, I'm not going to focus on the six areas that are often cited in terms of resilience, but what my key focus is around climate. So with all the attention that has been placed on COVID, up to date, it's roughly caused 2.7 trillion in terms of economic damage. But the expectation and the modeling around climate impact is show that it will cost the economies 54 trillion by 2040. But there are different things in terms of what's happening with COVID and what's happening with the climate, and I'll talk about those two in a little later. And so when you can see the resilience, it's really about the resilience to the chronic response in terms of climate that'll go on significantly, and the response to things like COVID, and further up that line, the things like tsunamis and earthquakes. So there is a spectrum of shocks and stresses, and climate falls on the chronic side. So who will benefit? So it's very key to understanding that it's about resilience for whom. So that resilience can be around policymakers, it can be around designers or planners, all the way. There are different operators. I'm sure a lot of people in the audience and policymakers wondering why they're not at the center. But ultimately, it's the individual, the people, all the way to the people who run assets or operate infrastructure, and all the way up to the policymakers. And they're improving the outcomes for the health, well-being, and those people, those most vulnerable, is really important in terms of this level of resilience. But it's resilience to what? And this is coming back to my first introduction. So the key part here is to recognize that the shocks or stresses, they're not predictable, they're not monolithic. So what they said in terms of Texas last week is that this is going to be a once in a lifetime challenge, but it's actually not a once in a lifetime challenge, because the exact same challenge was happening on the West Coast in terms of fires and the impact that was having on the grid in California. So it's about recognizing that there are shocks and there are stresses, and what resilience means, it means adopting your habits, your systems, and your strategies, and responding with some level of confidence to the spectrum of the challenges that they're affecting. And the resilience then to climate is the cumulative effect of climate over a number of decades. So there's a number of different types of index that are being used in terms of quantifying resilience, but let me focus on and ground this in a practical example. So I spent many years working in Cork, Cork subject to a lot of flooding, and what that would mean in terms of this resilience approach. So if I talk about health and well-being, infrastructure, the economy, it can talk really a little about shocks and stresses in terms of codes. But before I go into that, just one point on the shocks. The shocks are often covered by codes, regulatory standards. So and it's the response in the way that we design that is important in terms of responding to shocks. And say, for example, we have building regulations. One of the responses to a shock is to develop wind load and the impact that wind might have on our buildings, and that informs our regulation. So we actually, a lot of the responses to the shocks are covered within our codes. But what is covered in terms of what do we mean really by the stresses here? If the codes and the regulations can't help you, how do you, and when I talk about stresses, I mean chronic traffic or water shortages. These are the types of stresses that I think are impacting, and how you are resilient to, and what a lack of water, what stress that might place on you, or significant traffic within the town, what level of stress that might place on you. But let's go into the index here, and let me frame this out a little bit. So let's roll that there was potential flooding within Cork City. And what does that mean for building? How, from an infrastructure perspective, what do you do in terms of preparing? Do you build a wall around the building to protect it from flooding? Well, that is an approach, not the one that I'm proposing, but that is an approach. But that doesn't consider the full resilience index here. So the next thing is, what do you do in terms of your leadership and your strategy? Like, for example, if a building does flood, who closes the building? What is the plan in place for that building in terms of a response? Is there a strategy, and who leads? Who's responsible for it? The health associated, the health and well-being associated with the people who are within that building and surrounding that building, and who's looking after their well-being in terms of the resilience of a flood and the response to a flood. And then finally, the economy of it, the finance, which is about the kind of the building and the cost and the maintenance of the asset and all these different things. So there's lots of different dimensions to adapting and building resilience into the built environment. But it is in many ways moving from an emergency, which may be a flood, into a recovery, and having a plan in place to move from that. And that symbol of that recovery may be a revitalized building, more green spaces, utilizing of different types of green infrastructure around it, a healthier building, a better energy rating, and all these different things, to show that it's a symbol of a positive response in terms of a flood. And the physical impact of that flood and the economic value of that flood is represented more in a symbol of recovery. So let me just talk a little about data in terms of informing this discussion. So this is a source from the US, but every day in the US, a large number of architects and a large number of engineers rely on weather data that is outdated. So they're planning the design of buildings based on data that's outdated. And in many ways, we need to really design for the future and recognize that we do live in a changing world. And if you don't design and build for that future, changing climate, changing impact, then you may indeed end up with stranded assets. That's what Peter was talking about earlier today. We're moving from how do you consider the built environment in terms of future assets as well? And what type of building should you design now and build now, and how you consider the impact of climate in terms of that build? And is it a +2 degrees? Is it a +4 degrees, a +6? How do you ensure the resilience of that building for the future? And I'm going to come back to this point in a second. Give the example of a shock and a stress, so that had in terms of Sandy, and what happened in albeit 10 years ago. So 9 subway stations closed and 2 tunnels were all closed, causing billions of damage. But the future climate events such as this are expected to increase in both frequency and intensity. And the importance of the resilience to this type of critical infrastructure is hugely important. And that type of that resilience needs to be placed within context of infrastructure, of how you have an appropriate response and a plan to that. So as I come towards the end, there was a reference at the very start today in that we need to manage risks, we need to improve lives, and we need to achieve sustainability. And I would agree with all that, but it's actually, we do need to move beyond risk assessment as well. So we need to understand it, but we also need to manage it and put together creative solutions to it. So I'll give you an example here. These are some of the questions you can ask around it, but we are investing, the public sector is investing significant finance in terms of new buildings. And whether they're organizations or whether they're networks or whether it's the local authorities investing in the buildings or transport infrastructure that is investing, they are building and procuring assets on behalf of the state for the next 60 to 80 years. But how do we build into performance requirements to enable those assets to be resilient, to enable them to be robust and to be able to adapt? And what types of decision making needs to be put in place to ensure that actually the investment delivers confidence, it's the right use of taxpayers' money. We have considered the risk of exposure to things like hazards, and we do understand the interdependency of all these things to minimize the risk. So thank you very much.
Thank you very much, Matt. And I suppose you sort of reminded us that it's not, it's the changing climate that's occurring that is reducing resilience on an ongoing basis in terms of the extremes that we are currently experiencing and future extremes, and that needs to be part of our thinking for the future. Now, what I'd like to do is to move to the question and answer session, and there's been quite a few questions coming in. I think I'll start with an easy one first. Lisa, maybe you can answer that question about the correlation between Ireland's emissions from residential sector and the population growth since 1990. Have you got insights on that? Particular question from
I do, but when you say it's easy, Frank, that always makes me nervous.
Short.
In case I give the wrong answer. So there is not a correlation in the sense that population has grown, whereas our residential emissions, actually, from that first graph I showed, they have dropped. Although we're painting a very negative story here in terms of emissions, in fact, we have done good work, and residential emissions have dropped. So if you consider that in the context of a rising population, that, you know, we have done very well. In fact, I just looked up the latest statistics. So emissions per household have gone down from the residential sector by 39% over that period. So that's, you know, and that is due to thermal efficiency. But notwithstanding that, you know, we do still have a very carbon intense residential sector where, you know, a lot more needs to be done. And emissions, in fact, the residential emissions rose this year. Last year, 2020 was one of the only sectors during the COVID pandemic where it rose by, I think, was it? I had to look there, 8%. COVID emissions rose in the residential sector. So yeah, that's just because of heating increasing during that time.
Yes, and I suppose COVID is providing us with a quite unique experimental setup in terms of how we understand the dynamics between these various sectors, transport and housing, and emissions from them. But overall, I think your message is it's quite a good story. We are improving. Clearly, we have legacy issues, but we are improving, and future regulations will help us there. I'll stay with you, Lisa, for a minute, because a number of questions have focused on the rental issue and rental prices according to BERs and where we are with that. What is the messages we're getting from the market, so to speak? And I suppose we then break that into the ownership issues.
Yeah, there are a few issues here, and you know, the Irish rental market, I would say, is quite different to many other countries, mainly because on the residential side especially, we don't have a history of renting long term, you know, and so some of our rental properties have been quite poor quality because people maybe moved on quite quickly. So a lot of the research actually internationally on the energy performance of rental property has focused more on commercial buildings. There's a lot more, it's a lot more documented that commercial buildings with better energy performance, where they have got, sorry, I should distinguish, as Brian said, ratings does not necessarily mean better energy performance, but where they do have an energy certificate saying that they have a better rating, that in commercial buildings, it's a broad range depending on the country, depending on the type of rating system in place, but it goes between 0 and 23% for commercial buildings. So that's quite well documented, and that makes sense because, of course, investors in commercial building and also the renters would have they would be less myopic. They would consider the return on their investment. So they will consider the longer term performance of the building when they're renting it. Of course, householders are quite a different category. We don't, you know, do a cost benefit analysis essentially when we're moving into somewhere. And so although we may know that we would like an energy efficient property, we would know that we don't want to have to pay high energy bills. It's quite difficult for the vast majority of us to make that calculation just by being given a BER rating. So it is a lot more complex. What we are finding is that in Ireland, in the rental stock in households, that in cities you do find that where the market is already very tight, in fact in cities like Dublin and Cork, where rental prices are extremely high already, the higher rated properties are still commanding an even higher rental income. On the other end of the scale, the properties that have very poor energy performance or energy rating, in the cities, they are still implementing, they're not being discounted very much because they just, even though they have a poor energy performance, and that reflects the market tightness. Out in, you know, less tight places, so outside the rental pressure zones in Ireland particularly, you don't see it quite as much, and you do find that poor quality properties do rent for a cheaper rental income. So there are some things that are coming out of it, and I think we are doing more and more analysis with the good data that we have now from both the residential tenancy board property market and also the SEI energy performance. But there is still a lot more to do, and I have to say it's not particularly well enforced in terms of the advertising. So not all tenants coming into properties do have the full information or what it means. I think this is going to change because now the BERs are coming with advisory reports, especially for homeowners. That'll help them a lot in terms of what needs to be done concretely to improve the performance of their building. And that might make more sense to people, not just being told you have a D-rated property, but if you do this, this, and this, then you will have this level. You will move up to that level. So that should improve things.
Brian, can I bring in you on this topic as well? In terms of the responses to, I suppose, the market, is there lessons from Europe in how this might work in terms of where there's a larger rental cohort than perhaps there is in Ireland?
Yeah, there are a number of initiatives where, and a lot of this comes down to social trust in aggregation, and where you've got a groupie that will do as a one-stop shop the entire refurbishment and provide other benefits, maybe additional defensible outdoor space, as I showed in the photographs earlier on, turning additional volumetric parts of the building, etc. But done as a one-stop activity and involving a large amount of engagement, participation, and consultation with the occupants of the building. So you're minimizing, for example, the time that they're decanted out of their buildings. You need to take people out of their building. That's done well. It's done at times that are convenient to them, etc. So it's done from the occupant's perspective and also done at scale. Because if you do it at scale, you get the costs right down. And there's some very good examples, particularly in the Netherlands, either done by essentially charitable agencies, sometimes done by municipalities, but doing it at scale, but doing from the perspective of the occupant of the dwelling, so it's not being done to them; they're part of doing it.
Yeah, that's a very interesting insight, I suppose. And I think we'll come back to this. I think obviously the financial institutions and the regulators have a role on this. But I just want to, the other issue that's sort of come up in the questions has been the sort of life cycle analysis, that issue of embedded carbon. And obviously, we have a lot of embedded carbon in our building stocks, but at the same time, lots of them also lock us into highly energy inefficient building stock. And what are the trade-offs there do you see between, I suppose, demolition or refurbishment, or how do we optimize our stocks?
It's seldom the optimum is going to be demolition. The optimization of it is always going to be some form of refurbishment, and that might be quite a radical deep refurbishment. And interestingly enough, Ireland has settled for reasons of cost optimization around B2, but there are, if you look at the overall trend, that's part of then that cumulative European renovation wave. It doesn't actually achieve the desired carbon ambitions. Also, I should say that the energy ratings, as we discussed, essentially overestimate the amount of savings you can get from a stock by treating them as actually the energy consumption, because buildings are not as inefficient as the ratings would suggest. So you probably need to refurbish to a higher level than B2 ultimately, and there's a danger of locking in B2 at a certain level and then having to change policy. So basically, if you've got a building, refurbish it and have a very clear refurbishment to the highest possible standard that's economically viable to do would be the option. And there are very few occasions, and there'll be due to structural defects in foundations, things like that, where demolition would be the optimum solution. There are cases, but they're rare.
And I suppose that segues into what Matt was talking about in terms of the resilience. If you are renovating a building, how do you ensure you're renovating it for the future climate conditions? Matt, do you want to say something about that? How are we dealing with that? Are we embedding the right framework for getting the efficiency and the resilience? Is that fully in place yet?
So it's not fully in place, and you need a lot of people collaborating together, I guess. So considering resilience would mean everything from the design to the way that the asset or the building is managed. And that it's fairly straightforward for the residential sector, Frank, because you can build now and it can be built this year. But just imagine if you're building a hospital or you're building a large scale facility, and it might take a number of years to build, then, and that the lifetime of that asset is quite lengthy. You want to make sure that even in the short term, as you design, plan and build for something based on current regulations today, and something that actually just gets built in, say, 2026, 2037, how you ensure that that's resilient in terms of its design and the impact that can have. Now, there are certain things that you can do around, there are tools around carbon, life cycle carbon assessment. You can bring more kind of different types of investment decision making. You can apply more sustainability criteria into your design and your decisions in terms of, and conduct risk assessments around that design itself. But ultimately, you do need to be looking way beyond existing big building regulations to enhance that resilience.
And I think I'll come back down the line before I move back. But all of that, if you enhance the design, that all costs more. And I think Brian brought up the issue of fuel poverty, energy poverty. If you're asking people who, as Lisa said, they're not going to be looking at this when they want a building, and we can see the rental market, people still rent at very high rates in efficient buildings. So what are the solutions there in terms of finance? Matt, we'll start with you perhaps again.
So in the residential sector, there are different options in terms of business models, and the policymakers at the moment seem to have adopted a grant model, you know, in terms of overcoming the barrier associated with reducing the gap. And that's a fine model. I suppose the way that model gets delivered to enhance retrofit across a number of buildings then is challenging, because applying that model on a building or a home by home basis, when you really should be considering clusters of homes or communities approaches, and how you would demonstrate that. I suppose the question comes around from a commercial side, it comes a building or public building comes around payback, and actually what type of financial instrument that you want to use to enhance the payback. Now, whether it's a greener type loan or investment loan that you come to overcome the challenge of the upfront costs associated with that retrofit, different types of financial models there. And our financial institutions need to stand up and start delivering those types of instruments to the market at a much lower rate than they are at the moment. Compared to the European institutions, they're very poor in terms of percentage rates. And again, these then become deterrents for either the business owner, the building owner, the homeowner, to actually draw down the appropriate finance to deliver on the retrofit. But new business models, new financial, and whether some of those might be around a recycling fund, revolving fund, where investment happens and use the energy rewards that you would get in terms of efficiency savings to pull back in and to pay for other parts of the retrofit.
Brian, I'll sort of shift that question to you. And I think, you know, we're looking at the climate challenge here. And Peter Thorne made it clear we need to get to net zero CO2 by 2050 at the latest, so to speak, if we're certainly for Ireland to be climate neutral by 2050, probably before that. So how can we package this together with, a lot of people are bringing up solutions such as storage, such as energy management system, heat pumps. Can we put a package together that sort of addresses these financial barriers and works? Matt has emphasized the community side of things. But what's your take on all of these?
Yeah, there are a variety of models for packages together. The key part is identifying the private good and the public good in this, and there are private benefits, particularly the social sector, aggregating rental costs and energy costs, so that the payment to the social landlord, for example, the social housing provider, that the tenant makes is both of those. And in refurbishing the building, obviously the energy cost is going to go down. You might pass on some of that saving to the tenant, but maybe not all of it, which then gives you a revenue return on a long-term loan that's taken out to pay that, and that there might still be a gap which would need a state subsidy. So there are a variety of models in there that can do that. There also, I think, is a very important role for regulation that requires certain things to happen. We've got building regulations for existing buildings. There needs to be building regulations for refurbishment, but put the onus on landlords in particular, because the challenge is actually going to be those on low incomes, in fuel poverty, etc. in all of this, to do that, but have state agencies from which they draw on, if you like, the equivalent kind of mechanisms that would be available to social housing providers. So there are some possible models, but it does require a framework, and it does require quite a bit of regulation in terms of how that actual market organizes, so that it's not gamed.
Okay, so there's risks there. There's a lot of risks there. Lisa, could you sort of focus that down on Matt is saying we need the institutions to step up to the mark. We have these risks of gaming the system. How can we, and we do have to realize the potential of our building stock in terms of being part of the solution and not the problem. So can you sort of encapsulate that from I suppose, the economist perspective?
Yeah, I think Brian raised an important point there in understanding where the private good and the public good lies. Right now we have had a grant-based scheme, and it has been effective, I suppose, in kickstarting the market in terms of investing in energy efficiency. And the first grant schemes were very much about shallow retrofit, whereas now we're moving into deep retrofit, and we're moving into much larger scale systems. So we do need to rethink it quite a bit. The problem with grant schemes is that you're assuming that people already have a certain amount of capital themselves. So of course, then the groups that are targeted through it, well, they're not targeted, but that end up taking it up, they do tend to be homeowners, middle class people, whereas what we need to be doing is really focusing on the low quality stock. And so we do have some other schemes there. I mean, I think there is recognition increasingly on the policy side. We have the warmth and well-being scheme. We have schemes through local authorities and this really makes sense, where you can address like larger scale sort of social housing properties, for example. The warmth and well-being is where HSE targets low income or vulnerable groups that have maybe underlying health conditions. So I think this is the right step. We also have our sustainable energy community schemes, better energy community scheme, but there you see quite a lot of kind of community buildings and maybe some commercial buildings. It's a mix of buildings, and we really need to be trying to make that model work for more residential buildings. So, that they do get bonuses for having residential buildings, but I guess they're just that little bit fiddlier. And that is the problem with energy efficiency overall. There isn't just a blanket model where you can invest a few million and they're all the same. So it is very challenging. I do like the scheme, like KfW, the public bank in Germany. They've been up and running for a long time, and they do a lot of renovations. And their model is basically that they give cheap money to the commercial banks dedicated to energy efficiency, because you need the financial institutions getting involved, as Matt indicated as well, but they're probably not going to, it's quite a technical area to get into, and it's difficult for them to evaluate individual energy efficiency projects. And I think the risk that we have to take is there will be some free riders, but what you would like to see is that the financial institutions are really pushing and creating some of that demand there, in conjunction to regulation, as Brian said. So if there's a regulation there, then landlords will have to invest in better quality property and energy efficiency, but they do need to have very good access to cheap finance that will enable them to do that. So you need this combination all the time of regulation, the information there, so they know immediately where to go to even find out. A lot of people, they would like to improve their houses, but the idea of starting from scratch, where do they go? What's the thing? They hear about heat pumps. What is it? We did some focus groups. Nobody really knew about heat pumps. They knew what an EV was. They knew what solar PV was. They didn't know what a heat pump was. So you need this information, and then the access to finance and price signals pushing them, enabling it along the way. So it's a lot of things together.
We're just coming to the end now of this session. Just quickly, what is the first thing you would do if you could do it in terms of the next step for building owners in general, and what would you avoid most? Or maybe, do you want to think about that?
Well, what I'd avoid most is driving it with price signals, because I think that would lock in fuel poverty. And so I think so not using things that are entirely reliant on fuel price signals to drive behavior. I think that would be one thing to avoid. In terms of things to avoid, I think insisting that you have some form of building regulation that requires the refurbishment of existing buildings as a regulatory standard going forward, and then as Lisa said, a lot of other mechanisms then flow from that.
Avoiding price signals. Oh,
well, avoiding price signals being the only driver. Okay. You know what I mean? So yeah.
No, I spend a lot of time working with economists, and you're speaking heresy there almost in terms.
Well, yeah, but certainly from a fuel poverty perspective, it will be disaster.
It'll be disaster. Okay, that's clear, strong message. Better regulation. Matt, I'll come back to you, Lisa. After.
Yeah. So it's great if communities or individuals want to make the change and do a retrofit of their buildings. But they will soon find that maybe the people who are in the market are not trained to install to the appropriate level to get to that retrofit. So we've had, since 2008, there's been very few people trained in terms of installations. And if the public aren't aware of what heat pumps are, then maybe the installers, this is an opportunity to retrain, refocus in terms of delivering, because the major risk I see is that an individual actually who does either have some resources financially or goes to get to an institution to get a loan that's the same rate as a car loan for the retrofit, and then actually has a really bad experience because the installer does not know what they are doing in terms of delivering on the retrofit. So training, capacity development.
Okay, avoid the cowboy, so to speak, and have a.
Well, there's no mechanism to avoid them because you're on your own when you go to select your contractor.
Okay, Lisa, have you any thoughts to close us off?
At the risk of sitting on the fence, I agree with everybody, except I'd couch it maybe a little bit differently for Brian. I mean, I do believe, I am an economist, I do believe in price signals, but I agree completely with you that they can be regressive, and we do have a fuel poverty issue in Ireland. So you have to be very, very careful and, compensate those people. But so that's why I think first thing would be to, we have a lot of houses that are off the gas grid in Ireland. It's the same for transport, actually, that we have houses where you could target, they're still using solid fuel, some of them, and they're all using oil for sure. Well, they're either using solid fuel or oil, most of them, to heat their homes. So I think they should be targeted, and especially oil. A lot of those houses the people are not comfortable in them. They're cold, they're very, very expensive to heat. And I think they should be targeted with a retrofit and heat pumps, particularly, especially switching out those oil boilers. Don't let them skip the step of the gas boiler and go straight to a heat pump. I think they would be ones. And then maybe trying to limit planning a little bit. This is moving on to transport, my other hobby house, that maybe try and be more cohesive in building communities in terms of all these one-off houses that are very large around the country, that we could manage that a little bit better. I mean, they are meant to be A-rated, but it's still, in total, they will still consume quite a lot of energy because the A rating is per meter squared. So if we could target the houses with heat pumps and then also limit the one-off planning.
Yeah, okay. No, it's a fascinating issue, and unfortunately we have to close now. But I think what we need is a systematic, structured approach to going through addressing bit by bit those issues, from rural fuel energy poverty, city energy poverty, those who are really well capable of taking advantage of the system and progressing it on their own. So I think what I have to do right now, since it's just 3 o'clock on my computer clock, which may be wrong, of course, is basically to thank Lisa, Brian, and Matt for a really excellent set of presentations and for an excellent set of responses to the questions that came in. I think we've touched on at least some aspects of nearly all the questions that came in. So thank you very much. And we'll close this session, and the next session will start at 3:25 on sustainable transport and behavioural change. And Margaret Ward from Clear Inc. will be chairing that session. So thank you all.